Welcome to YCAD Wonders. This is Ganesh from Bangalore. So last video, we looked into the concept of HCF and LCM of two numbers. Okay, so here in this video, let's see how to find HCF and LCM of three or more numbers. Actually, same concept can be extended to find HCF and LCM of more than two numbers. Let's say, okay, we want to find the HCF and LCM for the numbers say 18, 30 and 54. Okay, so now let's use that common division method. That's one of the methods of finding HCF and LCM. 18, 30, 54. Again, as I said, if so to divide them, see, we need not use prime numbers. Suppose you are able to divide all the three numbers by composite number, it's fine, we can divide. See, for example, all are divisible by 6, isn't it? We can divide by 6 directly. So we need not divide by 2, okay, and then 3. Okay, whichever way you do, we'll get the same result. Okay, 6, so 3 times, 5 times, 9 times. Okay, so now by what number you can divide? Is there any number by which you can divide all these three numbers? Any? No, isn't it? So in that case, we need to divide by only prime numbers. So we are able to divide all the given numbers by a composite number, it's fine, we can divide by a composite number. But if you're not, if all the given numbers are not divisible by, okay, by any number, then we must divide only by prime numbers. Okay, so let's divide this by 3. Then one time is not divisible by 3, so okay, leave it as it is, and this one 3 times. So now again we need to divide by prime number, so 3, 1, 5 and 3. Okay, so now 5, sorry, this is 1, 5 and 1, okay, and this one by 5, 1, 1, 1, that's all. So that's the end. Okay, therefore, okay, as I said, so HCF means what? The product of all the numbers by which you divide all three numbers given. So only one, okay, here. So only the number 6 divides all the three. So therefore HCF is 6. And LCM is the product of all the numbers. So 6 into 3 into 3 into 5. So it is equal to, so 6 into 3, 18, 18 into 15, so 20. So it is 270. So 12, 15 plus 12, 27. So LCM is 270 and HCF is 6. Okay, which is same way, just like we found HCF and LCM for two numbers. Okay, let's use the prime factorization method, okay, to find HCF and LCM of the same set of numbers. So if you prime factorize 18, so it's you will get so 2 into 9, so 2 into 3 square, this is what you will get. If you prime factorize 30, so you will get so 2 into 3 into 5. If the prime factor is 54, you will get 6 into 9, 2 into 3 into, sorry, so it's 27 into 2, so 2 into 3 is cube. See if so you can find say you can find, suppose you want to find the say how to prime factorize 54, you know I told you in the earlier video. So let's divide by see it's divisible by 2, so 27. Now it's divisible by 3, 9, divisible by 3 times 3, 1, correct. So 2 into 3 into 3, understood. So 2 into 3 square, okay. So same way, so like this you can prime factorize any given number. Okay, now HCF, as I said, HCF is all common factors with least power. So here 2 and 3 are common factors. So here 2, okay, so 3. See here we have 3 square, here 3 cube. So smallest one is just 3, because 3 and that's all. So only 2 and 3 are common factors. Okay, therefore HCF is 2 into 3 6, and LCM, okay, as I said, say whether common or not, so we must take the product of all prime factors with highest powers. So here 2, what is the highest power? 2 only, 2 power 1, just 2. For 3, what is the highest power? 3. So into 3 cube, 3 power 3, and into 5. So which is equal to 2 into 3 into 3 into 3. So 3 into 3, 9, 9 into 3, 27. So this is into 5. See 2 into 5, 10, 10 into 27, 270. Okay. So same, see here HCF is 6 and LCM is 270. So 6 and 270. Okay. So we have found HCF and LCM by 2 different methods. But this concept, no product, see we saw, so product of any two numbers. So we saw product of two numbers is equal to product of their HCF and LCM. Okay, but this is not applicable for 3 or more numbers. So we cannot say here in this case 18 into 30 into 54 equal to 6 into 270. Okay, that's not applicable. So this is applicable only for two numbers. So that's why I say here product of two numbers. Okay, product of two numbers equal to product of their HCF and LCM. Okay, but see here then in simpler form, like see suppose there are the three numbers are co-prime numbers. Co-prime mean co-prime taken any two at a time. Okay, see for example 4, 7 and 15. See here, see taken see any two pairs you take out of this. So what are the see 4 and 7. See, 4 and 7 co-prime. Correct. See, 4 and 7 are co-prime numbers. Similarly, 7 and 15 also co-prime. And see, 4 and 15, they are also co-prime. So in that case, so HCF, there is no common factor. So therefore HCF is 1. So in that case HCF is equal to 1, and LCM is product of all the numbers. So 4 into 7 into 15. Okay, so 15 into 4, 60. So 6 into 7, so this 420. Okay. Yeah, so if they are co-prime, the given numbers are co-prime, taken 2 at a time. Any two numbers at a time, if you take, suppose they happen to be co-prime, then the HCF is 1 and LCM is their product. Okay, similarly, as in the case of two numbers, 3 numbers applicable, they are factors. Suppose say, okay, 6 so 18 and 24. So here HCF is easy. HCF, say here 6 is okay. So say 6 is a factor of 18. Also, it's a factor of 24. Correct. So in that case, HCF is 16. Okay, but LCM, yeah, you cannot. So we cannot say just one of them. So you need to use okay, prime factorization method to do this. Okay. Sorry, LCM HCF is 6, not 16. Because if this is the smallest number of the 3 is a factor of all other numbers, then smallest number is the HCF. Okay, in the same way, okay, let's say in the prime factorization we get let's say we want to find the HCF and LCM of 3 numbers A, B and C, and suppose A is equal to say 2 cube into 3 cube, okay, into 5 square, and B is 2 into 3 square into 5 square, adjust 5, C equal to 2 power 4 into 3 into 7, or 3 square into 7, let's say. Okay, now so how to so using this so what I'm saying is a is some number we don't know, a, b and c. Actually after prime factorizing a we get this so a is 2 cube into 3 cube into 5 square, and b is 2 into 3 square into 5, and c is 2 power 4 into 3 square into 7. Okay, now so what's the HCF of a, b and c? So HCF of a, b, c, so that's equal to, as I said, so identify all the common factors and take the use the least power and multiply. So here 2, what are the common factors? 2 and 3. For 2, what is the least smallest power? 2 only, 1. So just 2 power 1, just 2, because if there is no power, that means you have to assume to be 1. So 2 means 2 power 1. So and for 3, what is the smallest power? 2. So 2 into 3 square, and no other common factors, correct, because 5 is not common. 5 is there in only a and b, but 5 is not a factor of c. So 5 is not a common factor of all 3 numbers, so we should not take 5. So HCF is 2 into, so 3 square is 9, 2 into 9, 18. Okay, now LCM. So LCM of these 3 numbers is okay. So as I said, you need to take the all factors with highest power. See, for 2, what is the highest power? 3. So 2 power 4. So 2 power 4. And for 3, highest is 3. So 3 power 3. And for 5, what is the highest power? 2. 5 power 2. And 7 also there, other factor. So this, so all these 4 we need to multiply. So that means whether common or not, we need to take all the factors with the highest power, okay, and multiply. So we get so 2 power 4 is 16 into 27 into 25 into 7. So this is what the LCM is. So if you multiply, so you'll get 75,600. Okay, so this is the LCM of these 3 numbers. Okay, so any any topic, whatever topic, so you will learn, you should so as I said earlier in the introduction, okay, we need to understand the concepts clearly. So here so this is a easier way, prime factorization and common division method for to find HCF and LCM, because listing out the factors and multiples, so it's a time consuming. So common division method, actually that will be the easiest. So but if you know the any number in prime factorized form is available, like this here, a is given, a and b are, a, b, c are given in the as a product of factors. So in that case, okay, it's easy to use this method to find HCF and LCM. I hope it's clear to you. Thank you.